Hey, good evening. My name is Peter Kariva. I'm the CEO and president of the Aquarium here. And I know many of you are returnees, but for those of you, this is the first. We have a series called First Wednesdays. And the purpose of First Wednesdays is to connect the community, people, to nature, and to animals, and also to environmental issues. And I think we have a terrific one lined up for tonight. I want to acknowledge our sponsors here because this wouldn't be possible without the sponsors. The Courtyard by Marriott and Steve and Brenda Olson. And tonight, I don't really do the fancy introduction thing, but I like getting to know our speakers a little. And what really strikes me about Emilie is that she was a fine arts major. And look at where she is now. And then she got interested in sustainability. And she'll tell you about her work with bees. But the company she helped build is a B Corp. And those are corporations that, it's not the B Corp, it's not a pun. A B Corp are corporations that are done for public good. And they're really on the increase in the country. In my old job, I used to work a lot with B Corps. I think it's inspiring to see somebody so talented just making a good business out of something that makes us a better planet to live in. And the other thing I want to say about bees, you know, in Greek mythology, bees were messengers from the gods. And the reason they were messengers from the gods was because mead was the beverage of the gods, and bees brought mead to us. I was disappointed that Dina didn't get mead for us, but maybe the next time we have you back, we can have mead. So, take it away.
Thank you, Peter. Thank you so much for that introduction, Peter. Yeah, so thank you so much for being here tonight, for stopping by. I am really delighted to be here at the aquarium, and it's kind of fun tonight to be taking a few steps out of the ocean and into the honeybee hive, so to say. So I am really delighted to be able to share such a passion of mine with you all this evening. To get started, I wanted to share with you one of my favorite videos. And believe it or not, this was actually the very first slow motion video I took on my iPhone in 2016. And it was during a honey harvest in Quebec, in Canada. And these wonderful creatures that we see flying here in this video, you might even see them bump into each other now and then. They are at once builders and caregivers and foragers. They have the ability to fly for miles and miles in one day, carrying up to twice their body weight. And they are going to push themselves to the absolute maximum every single day. And while they are carrying out their work, they are quite literally going to be giving life to the world around them. And I am so excited this evening to introduce you a little bit more to these creatures, as well as some other absolutely incredible species of bee. And so, to say a few more words about who I am. So, as Peter mentioned, I am a beekeeper and a nature educator. There we go. And sorry, just give me a second. Yeah, and I grew up on the eastern kind of side of Canada in Montreal, Quebec, and that is where I started keeping bees. And a few years ago, I moved over to the western side of Canada, and I'm now based in Vancouver, BC. And I'm not sure if there are any beekeepers in the audience tonight, but if there are, you might be able to relate, to the fact that for me, moving across the country to a completely new region and learning to look after my honeybees in this entirely new climate has been a totally exhilarating and challenging and my favorite beekeeping journey so far. And it's been really fun for me to be down here with our Southern California team to learn a little bit more about their season and kind of the ins and outs of how they have figured out how to look after their bees down here. Because everywhere you go in the world, for beekeepers, the strategies and the challenges that you run into are going to be totally different. And in beekeeping, there is truly always something new to learn. And I've really found, or I should say, I'm not only a beekeeper, but I am also an urban beekeeper, which essentially means that the colonies that I look after are installed in urban spaces, which means that they're also close to people. And all of the beehives that myself and my colleagues install in cities are really there for the purpose of education. And in my nearly 10 years of beekeeping, I have had the absolute joy of opening up and sharing honeybee colonies with thousands of people. And it tends to look a little bit like this. And it really never gets old. And I found over the years that a shared experience and a shared curiosity surrounding honeybees to be this incredible point of entry to sparking conversations and questions about the role that pollinators play in our food system, as well as the role that they play in the urban environment around us that we all share. And the honeybee hive really has a special way of bringing people together, and you might be surprised at how learning more about this creature can make you feel more connected to so much around you. And so to kind of get into honeybees, when it comes to honeybees, there are some things that we already tend to know quite a bit about. We tend to know a lot about what bees provide for us. For example, we tend to know that they make honey and that they make beeswax as well. And for some of us, we tend to know that there is some kind of connection between bees visiting flowers and allowing fruit and vegetables to grow. But bees probably seep into your life way more than you would think, whether it be in the cotton or the linen clothing that you might wear, or for some of us, maybe even in the products that we might put in our hair. From the honey in your cupboard to the cough drop or the lip balm that you carry in your pocket, all the way to countless aisles of the grocery store, bees and their impact are truly all around us. And on the subject of bees kind of seeping into our lives more than we would think, did you know that globally there are over 20,000 different species of bee? And they're all absolutely incredible. In North America alone, we are home to roughly 4,000 different species of bee. And you lucky folks in California are home to roughly about 1,600 different species in this state alone. So I'm very jealous of you guys down here. And as it happens, all of these bees that we see in this image are native to this general region of Southwest California. And some of them are pretty cool. I had a really fun time researching them a bit more this past week. But so of these kind of 20,000 different species of bee in our world, some of them have incredible colors, like this pretty fantastic metallic green sweat bee, who some of you might recognize. They're quite common. Some of these bees can also be super, super fluffy and pretty adorable, like these red mason bees. So these guys are covered in thousands of tiny hairs that make them really fantastic at collecting pollen, attracting pollen onto their hairs and then kind of packing it into their pollen baskets. And some of these bees worldwide are absolutely teeny, teeny tiny, like this very special pale miner bee, who's one of my favorites and who only lives in small pockets of Canada and the US. So some of them are very tiny and others are not so tiny, like this pretty big valley carpenter bee who is very common here. And this is actually the male valley carpenter bee who is often nicknamed the teddy bear bee, understandably. And he's on my bucket list. I really want to see one in person one day. Some of these bees almost seem like they're out of a fairy tale with really cool nest building tendencies. So this is a very cool species of mason bee that makes her nests out of flower petals, which I think is pretty stunning. This is another image of what these nests look like. And some of these bees even create a bioplastic that they use to coat the inside of their underground nests to make them waterproof. And these are often referred to as cellophane bees. And some of these bees worldwide have co-evolved with one particular type of flower. And often in these cases, these bees will live only for the duration of that flower's bloom. And the squash bee is a great example of one of these kind of pollinator-flower relationships. And believe it or not, there is actually only a small handful of these 20,000 bee species that live in the booming social colonies that we tend to picture when we think of bees. And it's only a small handful of these highly social bee species that turn nectar into the harvestable liquid gold that we know as honey. And of this small handful of honeybees, there is one species that we find in most beekeepers' hives in the Western world, and that is Api mellifera, or the European honeybee. This is another one of my iPhone photos, which I'm stunned by. And because of this bee's overall very gentle nature and her high honey yield and her skill at pollinating many different types of flowers, she's become a bit of a poster child for all bees. And it's important to mention that in the media, oftentimes when people refer to bees, they're really referring to the European honeybee or beekeepers' bees. So honeybees get a lot of attention. But despite the world's bees' drastically different appearances and lifespans and characteristics, what unites all of them are these extreme feats of dedication and of strength that they are going to accomplish in their very short life cycles. And pretty much their entire lives are going to be completely devoted to collecting enough nectar and enough pollen and laying enough eggs to ensure that their offspring grow up healthy and hardy and ready to pollinate the next season's blooms. And without their devoted work, a lot of the vegetation around us wouldn't be able to reproduce. So though they are small, their impact is huge. And while many of these 20,000 bee species exist in pretty small numbers, and some of them mostly under human radar, others, like I've kind of mentioned, we have learned to manage and to raise over the years. And these species have become pretty important to our food system. And we're going to talk more about these four characters in a few minutes. But with my next image, I would love it actually if you could raise your hand if you have eaten one of the foods up here in this image in the last 24 hours. We've got some heavy hitters in these photos. We've got coffee and chocolate. You might even notice cheese down here, and that's representative of all dairy products, in fact. So it's really not surprising at all to have seen so many of your hands raised. And you've likely assumed already that all of these foods that we see here are supported by pollinators. So it's estimated that pollinators are responsible or that bees are responsible for the pollination of roughly a third of our diet. And there's some numbers that I think are really interesting to look at to understand the impact of pollinators within our food systems. And the following statistics are from the Food and Agriculture Organization of the United Nations from 2018. And so, firstly, across the globe, 75% of crops that produce fruits or seeds depend on pollination. And of our leading food crops worldwide, 87 of them are supported by pollinators. And these crops represent up to 35% of global agricultural land. So we're a third of our land. And another very important thing to mention is that these pollinator-dependent food products are really major contributors to healthy diets and to nutrition. And if we were to put it into an economic perspective, these pollinator-dependent food products, they are estimated to be worth up to $577 billion globally per year. And again, these are from 2018, and these numbers continue to go up. So clearly, if bees, both managed but also wild, if they were to disappear, our food system would, as we know it, would collapse. And not to mention much of the wild vegetation that makes up our world's ecosystems. So pollination is just as important for most plants as water, earth, air, and sunlight. And this is important to speak about at the moment because there are several practices within our society that are pretty heavily impacting pollinators. So most of our crops are currently grown in industrial monocultures where one single crop is planted over sometimes hundreds of miles of fields. And this single crop planting can become quite vulnerable, and it requires the use of significant use of herbicide and pesticide in order to maintain it. And pollinators come into contact with these chemicals when they are sent out to pollinate these fields. And in order to pollinate these crops, beekeepers actually need to be contracted to bring in their hives for pollination. Because this monoculture environment isn't conducive to having pollinators be able to survive year-round. Because although these fields grow tons of food for humans, they unfortunately are essentially food deserts when it comes to pollinators, save for those few days out of the year when these crops bloom and when they need to be pollinated. And so it has quickly become the norm for beekeepers to have to transport their bees over huge distances around the country, trying to make it to the different blooms for the different blooming times. And this makes it really tricky for beekeepers to have enough time to let their colonies recover from pesticide exposure and from the kind of poor single-source diets that the bees consume while they're pollinating these single crops. And it also makes it kind of tricky to control invasive pests like the destructive Varroa mite, who you might have heard spoken about in the media before. So honeybees, unfortunately, they end up becoming almost like collateral damage sometimes in the growth of our food. And not to lay it on thick, but our native bees are experiencing some pretty serious habitat loss as well, due to urban sprawl and agricultural land expansion, as well as increasingly due to the changing climate. So native bee populations are struggling to thrive as they once did in their natural habitat, with building and agricultural developments at the moment giving pretty little consideration into planting species that reflect the native flora that these bees co-evolved with, the native flora and their nesting habitats as well. But so while our current agricultural system doesn't take the health of pollinators as the serious priority, as I believe it should, it is really fascinating to learn about some of the species that we have learned to work with and to manage, and that we have begun to incorporate in our food growing over the years. And learning about how pollinators are involved with our agricultural systems can really help to understand the impact that bees have when it comes to our food. So this is when we get back to these four characters that we saw briefly earlier. So to begin with, I wanted to take a look at the beloved bumblebee, who is often one of the most recognized types of bees next to honeybees. So bumblebees have a kind of special relationship with one particular type of crop, which is pretty ubiquitous, and that is tomatoes. So tomato flowers are really interesting, and some of you might recognize them if you grow them at home here. But flowers come in all different shapes and sizes. They can be really long and skinny. They can be kind of flat and open. Some flowers even kind of hide their nectar and pollen. But tomato flowers are particularly interesting because they need to be what is called buzz pollinated. And this is a type of pollination that not all pollinators are able to do. So essentially, the flowers need to be kind of shaken in order to release their pollen and fertilize the egg in their ovary and grow into a tomato fruit. And in nature, this tends to happen by the wind. So the wind kind of passes through and shakes the flowers, and they're successfully pollinated. But increasingly, tomatoes are being grown in this environment, so in commercial greenhouses. And there's not very much wind in a greenhouse, and so the tomato's kind of bumbling companion has to be called in for help. And so bumblebees have this ability to kind of latch on to tomato flowers and kind of shape them at the perfect frequency to release their pollen, and that's buzz pollination. And so in many commercial greenhouses these days, we find bumblebee nests kind of installed throughout, which I think is pretty cool. And another interesting thing to note is that peppers are another common greenhouse crop that also really benefit from the presence of bumblebees. So our next pollinator is a really cute little pollinator who is increasingly being embraced kind of as an addition or as a replacement for honeybees in the pollination of fruit tree orchards. So for crops like apples and for pears, as well as some others as well. And so this is the blue orchard mason bee. And she's native to a pretty significant swath of North America. And mason bees, like many bee species, are solitary bees, and they lead pretty self-sufficient lives. And they only emerge for about 6 weeks in the springtime, which is kind of right in line with fruit tree blooms. And each adult female is going to spend her entire 6-week-long lifespan foraging as much nectar and pollen, and as I mentioned, laying enough eggs, as many eggs as she can, to ensure healthy offspring for the following season. And she creates her nests in hollow tubes, which in nature is often hollow plant stems. And in each one of these tubes, she's going to fit several little egg chambers. And again, some of you might recognize this nesting habitat from bee hotels that maybe you have yourselves installed, or maybe you've seen them installed in different gardens in your area. And blue orchard mason bees are a pretty common type of bee that people will try to attract to their bee hotels. But so inside her nest, I love this picture. This is a cross-section of one of those nesting tubes. Our blue orchard mason bee, she's going to mix together nectar and pollen into what is very adorably referred to as pollen butter, which is that bright yellow stuff. And she's going to lay her egg directly into that pollen butter store. And that egg is going to consume this kind of nutritious paste as it develops. And it will turn into a larva and then into a pupa. And eventually, they'll be fully developed bees ready to kind of emerge out of their tubes. And the mason bee will kind of separate her egg chambers using a mud wall. And that's where she gets her name of mason bee from. Yeah, and so something that is really interesting about mason bees, really cool and common, is that in their pupal stage, they actually spin themselves a cocoon. And although this next image isn't an image of a blue orchard mason bee, but it's very cute, and I wanted to be sure to show it. But this is roughly what it looks like when they spin themselves their cocoons. And over the years, mason bee raisers have kind of learned how to harvest these cocoons without harming the bees inside. And so increasingly, these blue orchard mason bee cocoons are being installed in fruit tree orchards, along with kind of new nesting tubes. And the bees will go out and pollinate the blooming fruit trees, and at the end of that blooming season, the mason bee raisers will come back and harvest those cocoons again for the following season. So the next pollinator I wanted to look at is a pollinator who is very deeply connected to our dairy products, actually. And this is the alfalfa leafcutter bee. And the alfalfa leafcutter bee is very similar to the mason bee in the sense that she is also a tube nesting bee. So this is another type of bee that you might find in bee hotels. And the alfalfa leafcutter bee, as her name would suggest, she has a very special relationship with alfalfa flower. And yeah, so alfalfa blooms, or I should say alfalfa is one of the main crops grown to feed dairy cows, and it's a really nutritious grass or plant. And alfalfa blooms with these really beautiful purple flowers. And it's actually a little bit tricky for pollinators for pollinators to pollinate, because although it is a really beautiful bloom, it has this almost kind of aggressive characteristic where it kind of hides its pollen, and it has a tripping mechanism. So when pollinators come to land on the bottom part of the flower, it releases the stamen, and the stamen kind of come thwack bees kind of right in the head when they come to pollinate it. So understandably, most bees actually kind of avoid alfalfa flower, whereas the alfalfa leafcutter bee, for whatever reason, doesn't seem to mind. So they're kind of a match made in heaven. And alfalfa needs to be visited by bees in order to reproduce. And so this is kind of how this bee is so deeply connected to our dairy production. And very similar to how mason bee raisers have learned to harvest their cocoons, leafcutter raisers have learned to harvest leafcutter cocoons as well. And where the leafcutter gets her name from is she has these two kind of special, she has these mandibles on the sides of her mouth, and she is able to cut chunks out of the leaves around her. And she will use these little leaf chunks to bundle together her little egg and pollen butter store. So kind of using a different technique than the mason bee to sort of separate these different egg chambers. So she'll kind of use her leaves, she'll bundle them up. So it's kind of like a bee rito. So I'm so happy you laughed. And so this is what that tends to look like when you have a handful of these leafcutter cocoons. And just like for mason bees, these cocoons will be installed in fields of alfalfa to emerge right as the blooming starts to pollinate those flowers, and then new nesting sites will be set up for them to come and nest in to then be collected afterwards. And now this brings us to the fourth pollinator that I wanted to have a look at, which is the honeybee, one of my favorites. And what really sets honeybees apart from other bees is the incredibly social nature and structure that they have. So while being managed by beekeepers, honeybee hives tend to look a little bit like this. So these are the standard American Langstroth hives. And in just one of these beekeeping boxes, so just one of the boxes that we see stacked here, if it was kind of full to the brim, you could find up to 50,000 bees living and working harmoniously in that relatively small space, which is pretty incredible. But more often, in each box, you'll find about 20,000 bees. And a colony's population will range throughout a beekeeping season from between 10 up to somewhere around 80,000 bees, depending on different environmental circumstances. And these bees will come and go from their entrance, which runs all the way along the bottom of one side of the hive. And sometimes you have to actually kind of watch the entrance for a few moments before noticing the activity. But once you do, it is really hard to look away. You'll see bees coming back with different colors of pollen on their legs, and you might see bees kind of stationed at the front, batting their wings and kind of airing out the colony to cool it off. It's pretty mesmerizing. But in a honeybee colony, we find three different members. We have worker bees who make up between 90 to 95% of the colony at different times of year, and they are all female. So there's a lot of girl power in a honeybee hive, which I really like about them. The second member of the colony are the males, the drones. They make up a smaller percentage of the colony, obviously, and they actually have a very small task list compared to their sisters, but they're still lovable. We still love them. And the third member is Her Majesty the Queen, the one and only. So in every honeybee colony, we will only find one queen, except for a few weird circumstances. And the queen bee is mother to all of the thousands of bees in her colony. And although all of her offspring, the workers and the drones, live for only roughly 1 month, the queen will live for up to 3 years, and sometimes even more. And the queen spends her entire day walking all throughout the colony, looking into cells to see if they are empty and if they are clean enough to receive an egg. And at the very peak of the beekeeping season, the queen bee can be laying up to 2,000 eggs a day. So this really isn't kind of a dainty, hands-off queen that we're talking about, although she does have a little entourage of bees that kind of follow her around, sort of doting and looking after her and feeding her, very importantly. And so because the worker bees have such a short lifespan, that's the reason why the queen has to be kind of constantly laying. She has to be constantly regenerating the population. And once a queen runs out of sperm stores with which to fertilize her eggs, the colony will actually raise a new queen. And this is how honeybee colonies can live for years under the reign of different queens. And I have a fun, I wonder if it's going to be a little bit too dark, but I have a beekeeper challenge for you. Can anybody spot the queen on this frame? I'll give you a few moments. So she's about twice as long. This queen is quite dark. It's a little bit tricky. But so our queen is found right there in the middle. So as a beekeeper, one of the first things you have to learn how to do is how to spot queens, and sometimes it is like finding a needle in a haystack because she really does move all throughout the brood chamber. But although the queen is very, very fascinating and has a lot of lore, in my opinion, the real star of the colony is really the worker bee. And we're going to focus on her for just a couple minutes. So when a worker bee is first laid by the queen, she looks like this, so kind of like a teeny tiny grain of rice at the bottom of a cell. And it will take 21 days for this egg to develop into a fully grown bee, ready to kind of emerge and join the workforce of the colony. And so pretty much from the minute that a worker bee emerges from her cell, she's going to get to work straight away. She'll spend a couple minutes kind of walking around her frame, kind of getting her bearings a little bit, and eventually she'll go back to the exact cell that she came out of, and she'll clean it out, and she'll make it ready to receive a new egg. So straight away, they get to work. It's crazy. And then something that's surprising to learn about bees often, about honeybees, is that the worker bees are actually not able to fly for the first half of their life, for the first 2 weeks of their life. So the first half of their life is really spent inside the colony, carrying out a whole multitude of different tasks that are all absolutely essential to keeping the colony running smoothly. And our worker bee is going to kind of transition into these different roles as she ages. So for the first few days, she will be working as a housekeeping bee. She'll eventually kind of naturally transition into the role of a nurse bee, so looking after the developing brood and feeding them. She'll probably work intermittently as a ventilator bee, so ensuring the constant or the consistent temperature of the hive and the constant airflow throughout the colony. And these bees will actually station themselves kind of throughout the box at strategic points to ensure that there's constant airflow. Sometime then around the 12th day of her life, our worker bee will begin producing beeswax. And similar to how we have sweat glands as humans, honeybees have, or worker bees have wax glands. And they produce beeswax in 8 sheets under their abdomen. And they will kind of remove these sheets and soften that wax and then mold it into their perfect honeycomb. And then somewhere around around being 2 weeks old, our worker bee is going to be ready to fly, and she's going to learn the Waggle Dance, which is this, and that is its real name, and it's this special form of communication between the forager bees specifically. And so the bees have this really kind of very specific choreography to communicate to each other where to find the best sources of nectar and of pollen that day. So depending on what angle they kind of shake along the frame and for how long they shake, they might be communicating to their sisters to, leave the hive and find the sun. And then, if you fly for this particular distance at this particular angle, you'll find blooming foxglove agave on the Manhattan Beach strand or something. But one of the reasons that I find honeybees to be such an important creature to know about, and particularly in the city, is because of the surprising ways that honeybees have helped me to feel more connected to my urban environment. And one of the most significant ways that they have made me feel more connected is actually through their honey. So honey in and of itself is absolutely fascinating, and I could talk about it forever, but I'll hold back. But it's really urban honey that has caught my curiosity and has really held on to it for years now. So to kind of explain just really quickly how bees produce honey, foragers will visit hundreds of flowers a day, filling up their special honey sac with nectar to bring back to the hive. And once they get back to their colony with this harvested nectar, they will then find one of their sisters and actually transfer the nectar from their stomach into the stomach of this other bee. And then that bee will then go on and repeat this process again with a few other worker bees, so regurgitating that nectar into the stomachs of many sisters, until eventually they will deposit that nectar into a honey cell. And then the bees inside the hive are going to begin working to kind of heat up that nectar to evaporate water from it, because honey is essentially concentrated nectar. And they are going to evaporate the water until that nectar boasts only a 17.8% water concentration. Very specific. And it's at that point that this newly transformed honey will never ferment. And it will keep for years and years. And this is what that looks like. We have open nectar cells and then cells that have just been capped over by wax, excuse me. And so the next image I'm going to show you is a photo of one of the most kind of bountiful harvest years that we had back in Montreal in 2016. And believe it or not, each one of these different honey jars is honey that is harvested just from different neighborhoods in the same city. This was in Montreal. So through urban honey, we end up getting this incredibly unique snapshot of different neighborhoods in the city, and a snapshot of a really unique combination of blooms that we find in different areas. And sometimes the history of the city can actually kind of be discovered through honeys. So for example, the lightest honey in Montreal is always harvested from the Plateau neighborhood. And in this neighborhood, in the 1940s, this neighborhood used to be full of these beautiful tall Dutch elm trees that kind of created these huge arches that met, kind of leaves would meet in the middle. But there was a big blight that kind of wiped them out in the 1940s. And all of these Dutch elm trees were replaced at the same time by what was kind of the tree of the moment, which were linden trees, or basswood trees, they're also called. And linden trees are amazing sources of food for bees. They produce thousands and thousands of really nectar-rich flowers. And linden trees produce a really pale and a really minty flavored nectar. And so every single year in Montreal, when we harvest the honey, the lightest honey always comes from the Plateau. And in every single city, you're always going to find kind of similar stories. And yeah, if you are able to stick around for a little bit after the talk is finished, the organizers, Adina, has actually organized a really wonderful honey tasting activity so that you can kind of experience some of this yourself tonight, which I'm really excited about. So, although a lot of the most severe effects on pollinators are taking place in our rural and our agricultural areas, there's a lot that we can do as urban dwellers to really help out our honeybees and our native bees as well. And although it might sound kind of simple, the best thing that we can do for them is to create more habitat for them. And the way that we do this is by planting flowers. But not just any kind of flowers, any type of flowers. We need to be conscious to plant species that are native to our region and that are identified as great species at supporting our native pollinators. So It's really, I'm seeing a few phones being taken out. I was going to encourage you to take a photo of this slide if you'd like. But these are the top 6 recommended flowers by the Orange County kind of chapter of the California Native Plant Society. I had such a fun time on their website this week. They are an incredible resource, and I really encourage you to Google them. I particularly was blown away by this website, calscape.org, where you can really easily enter your region, and it will show you some great local flowers. But yeah, so just to mention quickly, so California buckwheat is fantastic. I've learned that it is really great at attracting many pollinators, but particularly butterflies. Narrowleaf milkweed is another great flower for attracting butterflies, but particularly monarch butterflies, who actually rely on milkweed for their nesting habitat as they make their journey from Mexico up to Canada every year. And I'm assuming that a lot of you probably recognize a lot of these species, the beautiful electric blue California lilac. In California, you guys have over 150 native sages that are wonderful for bees. And California poppies and other native wildflowers are really wonderful options. And the best time to seed them is actually in the fall and early winter. So planting that seed early for you guys. And then manzanita trees are also, which is very cool for me to learn, are great sources of nectar as well. So to kind of conclude, over the years, through the different beekeeping projects that I've been a part of, it has been absolutely wonderful to see the impact that a deeper knowledge of honeybees and native pollinators has had on the people who have interacted with them. We're seeing more and more buildings that have honeybee projects begin to adjust their landscaping to better serve pollinators, whether it be doing things like reseeding their grass to flowering clover, or requesting consultations for us to come in and make recommendations for how their landscaping can better feed their local urban bees. And folks have begun to request more native pollinator programs, which is really exciting. This is a really fun project in Stuytown in Manhattan in New York. Here's another great example in just some of our projects, another one in Toronto that has been really great. And increasingly, we're also seeing more and more buildings convert their rooftops to grow food and to also grow flowers. And this is a really wonderful way of making use of some pretty underused urban space up on rooftops. And for all of these projects, the folks behind them, they cite their projects to their experiences with honeybees and their educational talks about other pollinators as the instigator. So as I mentioned at the very beginning, I find it really incredible how being just a bit more connected to bees can often make us feel more connected to the environment around us. And ultimately, I believe, to ourselves as well. And thank you very much.
We have questions for about 15 minutes, and then we go out and taste some honey.
Actually, I'm gonna come back over here.
Hi, dear.
Hi.
My name is Val, and I want to tell you what a wonderful presentation this was.
Oh, thank you.
It has created more questions for me about bees than I ever knew I had.
I love that.
But I do have one question for you.
Yeah.
What impact has the climate change had on the bee populations?
Yeah, that's a really fantastic question, and there's a really, a very layered answer to be given to it. And what I will say is that climate change has really been affecting our native bee, our native wild bee populations significantly. And more, there's an increasing amount of research being done on the effects of native bees. Unfortunately, native bees are often very solitary, and so it's a little bit hard to collect. I shouldn't say hard. It's a little bit trickier to collect data on them than our managed bees that, you know, we have such great oversight on. But due to the changing climate, a lot of these bees exist in pretty fragile ecosystems, and their habitat is changing really, really quickly. So unfortunately, I would want to do a little bit more research to give you a more specific answer. But as our climate is changing, ecosystems are really, changing very quickly, and this is very much affecting pollinators because we find pollinators everywhere in the world, and the smallest thing can really kind of affect them pretty deeply. Yeah.
Hi there. I have a two-parter. One, how many times have you been stung? I feel like you have to answer that question in the lecture. And two, do you have any reason or any intel on why it would take a larva 21 days to only live for 30 days? Have you ever heard anything about why that works evolutionarily for them? I'm just wondering. And then, I'll leave it at that. Thank you.
Nice. Yeah, I'll be hanging around afterwards as well. So it sounds like you have other questions, and we can probably touch on them as well. But first off, how many times I've been stung, I will never disclose. But I mean, honeybees are pretty amazing, and you learn really quickly how best to kind of move with the colony and how to work with them. So very quickly after your first or second season as a beekeeper, you start to get stung a lot less, but definitely your first season is like, it's really big, big learning curve. And over time, also, your body develops, hopefully, an immunity to the venom. And so it will always hurt when you get stung, but you stop having kind of unpredictable swelling and reactions to the stings, which is really the worst part of it. And then your other question, so it's really fascinating. So in terms of why those 21 days, that is a great question. But the reason why worker bees have such a short lifespan after they emerge is actually because during the foraging season, they work so hard. So they really kind of overwork their bodies, and that leads to them only living for those 30 days. But something that's very interesting, and it always kind of depends on the climate that you're in, but if we take colder climates up in many of our cities in Canada, there are winter bees that actually live for several months. And it's because they spend the entire winter, the colony will live throughout the whole winter. They'll stay inside the hive, and they'll work to kind of keep the hive heated to 35 degrees Celsius, which I'm not sure in Fahrenheit. I think it's 95 Fahrenheit. But very hot, about the temperature is it outside right now. Anyway, and so because those bees aren't flying around as much and they aren't kind of exhausting their bodies as much, they are able to live for longer. And the worker bees will actually raise the winter bees with a little bit more, they'll feed them a little bit more pollen, and so they'll actually be a little bit fattier and they'll have more to feed off of. So anyway, so it's really interesting. There is quite a bit of variation as to how long worker bees will live after they emerge, but during the foraging season, it's just like go time, and they just don't stop. Yeah, that's a really good question. Yeah, and I love this question. It's really funny because we're so accustomed to harvesting honey and to eating honey, and really the bees don't consider us at all when they produce their honey. But yeah, so the bees, honeybees really they have evolved to in every season a honeybee colony will, if it's a good season, they'll produce more honey than they would ever be able to consume in 1 year. And so if you are harvesting honey responsibly as a beekeeper, you are always going to leave the bees with enough honey to sustain themselves and a little bit more, and then you're only taking the surplus. But so bees are really great at honeybees are great at transforming nectar into that honey, bringing down that water concentration so that it doesn't ferment, so it can last for years. So they're essentially really great at just saving honey for a rainy day. But as a beekeeper, you know that you are looking after your bees, you know that you're gonna make sure they have enough food, so you're able to take some of that honey away from them, because you know that you'll be there to supplement if need be, and you know that you're leaving them with enough of what they need. And then beeswax, so the bees produce, as we learned, they produce the beeswax themselves, the workers do. And it actually takes a lot of honey to produce their wax. It takes about 8 pounds of honey to produce 1 pound of beeswax. So depending on the colony, a lot of the early sources of nectar that they bring in will actually go towards wax production if it's a colony that doesn't have a lot of honeycomb built. But yeah, the bees use they use their wax to build their honeycomb, and they use their honeycomb for everything. So they'll store one individual honeycomb cell over time, could be used to store pollen at one point. It might then be cleaned out and used to store honey, and then maybe it'll have a bee develop inside that cell. So it's this really beautiful kind of essentially zero waste society that they run, reusing their wax as much as possible. But yeah, so it's they very much make it for them and not for us, and we just responsibly can harvest.
What percentage is surplus?
Yeah, that's a great question. So when you're harvesting honey from a hive, kind of the rule of thumb is to leave between 1/3 and 1/2 of the honey with the colony, but there's a lot of different factors that would go into your decision making. For example, how large the population is. A bigger population of bees will need a little bit more food. Also what time of year it is. For example, if you know that you are heading into a big nectar flow, then you can harvest a little bit more honey from your hive beforehand, because you know the bees are going to be just inundated with a ton of nectar coming in. So there's a few different factors that go into it, but yeah, you always want to make sure that your hive has at least a few like really stacked frames of honey, and that's always kind of according to how much population they have. Yeah.
So my name is Sharon, and I've converted a portion of my front parkway to a pollinator area. One of the plants that I've put in it is called African blue sage.
Okay.
I've noticed that bees love it. I can't tell what kind they are, and I was wondering if it might be Africanized bees. I don't know what that means, actually.
Yeah, that's really interesting. And so Africanized bees are actually something that is one of the things that I'm always really excited to hear our California team talk about, because for me, up in Canada, it's really not relevant as of yet anymore. We don't have Africanized species. It's a little bit too cold. But yeah, it'd be interesting. I would, if you happen to have a photo on your phone, I would love to take a look and try to identify what those bees are. But I would say that it wouldn't surprise me if they were. They also might be regular honeybees too. They're like super attracted to lots of things, but many flowers, even if they aren't native to an area, will be very attractive to bees. And it's not necessarily a bad thing to plant these species at all, as long as they're not incredibly invasive. But if we're really thinking of our like native bees specifically and wanting to feed and create habitat for them, that's when those native species become super important for them. But sages are so attractive to bees. It's a great, great one to have in there.
So you said that when the queen bee can't lay eggs anymore, they raise another one, but where does that other queen bee come from?
Oh my God, this is a great question, and it is it's something that I tend not to mention in the kind of the core of my presentation, because it is so fascinating, and it's actually a little almost like science fiction-y how they create new queens. But yeah, so the worker bees, like I mentioned, they have the ability to create a new queen, and genetically, even though they have such different lifespans, the female bees, the worker bees, and the queen are, genetically speaking, identical. And what will make a queen bee is what she is fed as a developing egg and larva, as a developing bee. And so to create a new queen, the worker bees will start producing this substance called royal jelly that is super nutritious, and all of the worker bees get only a few kind of drops of this royal jelly as they develop. But the queen bee, they'll actually build kind of a special cell for her called a royal cell. And they will pack this cell full of royal jelly, and they'll choose a female egg that the queen has laid to kind of build this cell around, or the queen will lay directly in it. Anyway, and then as this egg kind of develops and grows, it'll consume this royal jelly, and it will develop quicker than regular bees. It takes about 16 days. And so you call these queen cells, and they look kind of like peanut shells almost, kind of sticking out at the bottom, often of frames or in the middle of frames. And the worker bees will always raise multiple queens at once, just to kind of ensure themselves in case anything goes wrong. And these new queens will actually typically emerge around the same time, and we call them virgin queens. And these virgin queens, once they emerge, will then, they have this little like queen call that they do called queen tooting. And it's kind of like a battle cry. And the virgin queens will find each other in the hive, and they will kind of like duke it out until there's just one remaining. And these virgin queens will also go after the original queen, and they will kill her as well. Sometimes, though, the original queen defeats the new queens, and that is really cool. And the workers were wrong, and they didn't need to replace her. But that's very rare. That doesn't often happen. Normally, they're replacing the queen because of a reason. But yeah, it's pretty crazy. And then that kind of victorious virgin queen will leave the colony a few days later, and she will hopefully be fertilized by males from neighboring colonies in what's called her nuptial flight. And that one nuptial flight is, if she's fertilized by enough males, that will be enough to keep her laying eggs for years. So it's pretty trippy. It's like a pretty crazy system that they have. Yeah.
Hi, my name is Diana. I was wondering if there's any genetically engineering initiatives that are thinking of cloning bees due to the extreme global warming and the environmental factors that are affecting our Earth?
Yeah, really, really cool question. Honestly, every day I feel like I am learning about new initiatives that are happening with people doing such interesting and kind of what feels like such futuristic kind of work with bees and what's possible with bees. I don't know, actually, if there are people who are actively trying to figure out how to clone bees, but there definitely is. For hundreds of years, really, if not thousands, beekeepers have always played with the genetics of bees, and queen raising is a huge focus for a lot of beekeepers in the beekeeping world. So that's kind of raising queens, and queen raising is amazing because you can really choose different genetics. And so this can be to produce more honey, or to be more gentle, or to raise queens to try to, raise queens to try to solve issues like varroa mites that latch on to bees' backs, and trying to choose genetics of bees who have the instinct to kind of brush those mites off. So there's really interesting things that can be done. Kind of experimenting with genetics.
One more question.
Yeah.
Okay. I actually had, first of all, thank you very much. This is so many questions I have now, but I'll ask both, and you can see which one you want to answer. The first one is, when they get out of their boxes and they become in wild, is there competition with the native bees? And then the second question, I'm probably not pronouncing correctly. Can you talk a little bit about
Neonicotinoids. Yeah, really, really great questions. Well, I'll say quickly, so neonicotinoids, because other people may have heard this as well in the media. So neonicotinoids are a specific pesticide that is used quite broadly in a few different crops. But these really particularly affect bees, and there are really big movements to try and have these neonicotinoids or neonics banned. And it's been in many different places in the US, in California, in Canada as well. It's been a bit of a kind of like 2 steps forward, 1 step back kind of thing. But a really great organization to follow is the Xerces Society, Xerces, and they are really wonderful at kind of lobbying for better legislation around pesticide use, very much with pollinators in mind, and insects in general. But yeah, great questions. Thank you.
So Game of Thrones has nothing on bees, I can tell you that. But after this, you go out the ground floor here, and there's a bar out there for drinks and some honey to taste and conversation. You can ask other questions. And I want to draw your attention to the next first Wednesday. We're going to have a fellow who is part of a global network who put together a book that's called Carbon Almanac. It's kind of like the whole Earth catalog for what to do about climate change. And he's donated them free here. So you're going to be able to pick up this book, and it's a fabulous book. And we're going to have a discussion about not the politics of climate change, more like the practical things you can do. It harkens back to the whole Earth catalog, which I remember. It's very much in that style. Or as I was mentioning to somebody, the catalogs I used to use for rebuilding your Volkswagen engine. It's not a glossy book, but it's really, really neat. So that'll be the next first Wednesday, the Carbon Almanac. But thank you very much for a terrific talk and questions. And let's have some conversation afterwards.
So everybody be sure to exit the theater downstairs, not at the top. And then the other thing I wanted to say is we have a few events going on this evening, but in this immediate area, we have a honey tasting, we have a cocktail bar, we have bee bracelets that you can all be making. And for those of you who came in a pair of 2 to 4 and didn't receive your second jar of honey, come see me at the bar.